Hello and welcome to this session of Statistical Process Control, how to build control chart for discrete data in Minitab and analyze them. If you are coming from one of the companion video who talked about the key principle or the continuous data, obviously there'll be a little bit of repetition as each file is meant to stand on its own. But very much the idea of the PowerPoint presentation slides is to give you some grounding and reference that you can easily go back through at your own pace if you need to. And otherwise, we'll follow a very similar approach as before, which is selecting the right chart, setting up the data, and run it in Minitab, and then obviously analyzing it. So let's start with selecting the right chart. Obviously, as I say, continuous data is out of scope here. In the discrete world, we are now in the situations where we need to be very clear as to whether we're counting specific defects or defective item. And for a lot of people, they may sound the same, but in a world of CI, these two are different. So defective item, if you remember, are things like good, bad, late, on time, yes, no, pass, fail, and so on. Defects are going to be things like scratches on a car or appliance, complaints, warranty claims, accidents, and so on, where you're counting the actual instances of a defect, whatever that defect might be. Okay, so let's look at the branch where we have defective items. The next question you need to ask yourself is, do you know how many were good as well as bad, and therefore have the sense of the whole population? If you are in that world, then yes, we will be able to proceed to the next question, which is your sample size constant? And then depending on the answers to that, you will select the chart. If your sample size is constant, because, for example, you're choosing to select 50 loan application every day, that will be using the NP chart. If, on the other hand, you are collecting the proportion of defective loan application out of the total population of loan application, then what you're going to be using is the P chart, okay? And those will be following what's referred to as a binomial distribution. If you're on the branch where you're counting the actual type of defects and how many of them are showing up every day, the third question is slightly different. What we are asking ourselves here is the probability of the defect low? If the answer is yes, hopefully, then the next question will be, is the area for opportunity of defect constant? So if I take the example of scratches on the car, if you're counting the paint scratch coming out of the paint job on a specific car model, obviously every single car of that model has the same paint surface. So the areas for opportunity will be constant, and so you'll be able to use a C chart. If, on the other hand, you're counting all the scratches, all the smudges, and other type of defect that may come out of the paint shop, for any car models, you're in a different world. You're in a world where that area of opportunity is not constant, and therefore you will need to use the U chart. So hopefully this makes sense. I just thought I'll give you some examples. They'll also be shown in the next slide for you to refer to. Now, if you are in a situation where either that probability of defect is now high, or you don't know the total population of your non-defective or the other side, whichever you decide to plot, for your total population, then you effectively just need to use an individual moving range. This situation is that you're effectively plotting data, which based on the number of count of data point you have, is going to be able to use the central limit theorem and approximate your data to be normally distributed, and therefore use the IMR. Okay, there's some caveat on that, but that's the essence of it. Continuing on this, I just thought I would also articulate other assumptions behind the requirements of the data that goes into control chart. Again, your data must be independent. So if I look at the example of my loan application, if a single customer or maybe an advisor has put in 3 loan application and systematically miss a section of information in that loan application that rendered that application defective, you will create a bias with things like that. So don't get me wrong, there are lots of processes where these things are accepted and almost suggested. So you just need to make sure how many of those do you have, and if they're very common, then it may be become part of the process and therefore acceptable. But if it's a rare occurrence, this will show up as probably some form of signal on your control chart, so you need to be aware of it. Equally, if we go back to the example of the scratches of the car, hopefully from this example you gathered that you need to be confident that the definitions and the method of data collection are stable over time. It's very common, and it's happened also in the world of defective, that as a process matures or we grow the product or we grow the services, that we put more and more into what's a defects or what's a defective item. And so certainly we're no longer comparing apple and oranges on the process chart. So you need to be aware of this reality, and sometime if there is a significant change in definition or data collection method, you will need to drop some of the data so that you don't have that situation of apple and oranges on it. And that obviously brings us to the usual limit, which you need to have 10 to 15 data point so that each of the 4 rules associated with control chart can be calculated and tested against. Obviously, again, based on the version of Minitab you have, these rules may show slightly differently for you with slightly different count. If you're not quite yet at the required number of data points, I would still encourage you to perform all tests. And as you gather more data from your process, you will be able to have all rules applied to your data set. Until you reach the minimum, these will just be ignored otherwise. Okay, hopefully that makes sense. So just a quick reminder, again, that defect and defective and how it pans out. So these slides, I'm not going to go through in details because effectively I talked through it in the previous slide, but I thought I'd give you a written version of it just in case for references. So how do we need to set up our data so that we can work effectively with Minitab? As with continuous data, and probably even more so in a world of discrete, you need to be really clear about the sampling and the subgrouping or segmentation, if you prefer to use that word, relevant for your process. Okay, Minitab will not be able to detect that for you. You need to have had the reflection with the team or the process owner as to what's relevant based on how the control chart will be used. And if you're creating a control chart for the first time for an areas of the business or a subset of traditional process, you need to go through each of these questions to make sure that then these are answered correctly and if performed correctly before you go automating. Okay, because once you start automation, it'll be a lot harder to detect these sorts of challenges. So making sure, first of all, that your counts of defects or defective warrants to use the right chart. As with any control chart, making sure you keep your date of data collection so that then you can sort it chronologically. Making sure your data is clean. Check for blanks and typos that are very, very common, especially around dates. And I have to warn you that unfortunately, when it comes to discrete control chart, Minitab will only accept stacked data at this stage. Maybe in later version, this will come through, but with the one I'm working on today, it's unfortunately not there. If, however, you have both your total defect or you have a breakdown of defects and you have a count still by date, there are options for you to create multiple graphs, which can be quite handy and minimize your rework. And so this is an example of how you will need to have your data laid out so that you can run these charts. Keep in mind that for the UNP chart, obviously, as I said, you really need to have the subgroup size included so that Minitab can run. For the NP chart, it will only need to be provided either as a constant number, which you can type in directly, or if it's easier for you, then you can again have a column and put the number in there. But obviously then it will need to be on every single row. All right. Quick heads up as to what I will be cover next, and we'll be again using Excel and Minitab to demonstrate how to perform all these tasks. These are some of the more common. Be aware there are lots many other options and more advanced features that if that's what you're looking for, I can create in a different video, or you can refer directly to the Minitab help function. Okay, so with that in mind, let's jump over to Excel and let's have a look at our data. So I prepare a set of data from effectively my loan and mortgage application process, because it's one that I know very well, but also something that we can all relate to. So for a bit of background, this is a sample of 20 days of business. You will notice that there is a jump between certain dates because this is a process that performs Monday through Friday. And I didn't want to have a potential weird thing happening on weekends. So we excluded those dates, and this is why you will have a jump in the dates, but then it will give you a nice continuity when you build your control chart. As mentioned, I'm capturing my total population, which is here is the total number of application. In my sample over 20 days, I've got just over 1,000 applications. Then I have a count of how many of those applications were not timely based on my upper spec limit for the lead time, and therefore by difference, how many were timely. Obviously, because I'm going to plot the defective item, I will be plotting the non-timely count. Now, in business, it's very, very common that this data would be reported as a percentage defective, and there's certainly nothing wrong with that. Just be aware that if that's what you choose to do, you would, in theory, need to use the IMR chart, because then this becomes continuous data. And it's certainly possible, but I'll show you in using this example what will be the difference in terms of potential output and therefore analysis. Okay. Now, as always, I have a small sample of data, so I'm just going to use the copy paste. If you have very large sample size, I would encourage you to use the import function available in Minitab. I will use the header, so I'm just going to select from this row and then down to select my data, and then jump over to Minitab and paste it in the header row. And then I'm going to go into Stat, Control Chart, Attribute Charts, and then I'm going to select my P chart, because if you follow the flow chart, that's very much the situation I'm in. I have defective item. I know the total count. The sample size vary, so I need to use the P chart. So variable is the not timely. That's what I'm actually interested in monitoring. The subgroup size for me is going to be the number of application. And then I will go into the scale option to use the stamp option to include the actual date of the collection. Now, these are the date when the loan was submitted and from which we start counting. Okay, if I wanted to include also a reference line, I could do so both for the date of access, for let's say I'm interested to understand what happened after the 23rd of January, which is row 11. So I would put 11 in here. And let's say I want to see a proportion. So because this is going to be shown a proportion, I want to see how many compared to my expected proportion of 10%, right? So let's say I want to see how many I get. So I would put 0.1, because 10%, for the Y. And then I'll see if this is my customer spec limit. This is a good way to show it on the control chart itself. So I click OK. OK. Before I do that, I'm just going to go into, obviously, the P chart options and select all test, so that if I have enough data, all these rules will be applied. And I'll come back in a minute on how to use another option that I discussed. So now I can click OK and OK, and it's going to produce a chart for me. So this chart, as a reminder, obviously we have our center line here, or the green line, which shows you the effectively the mean proportion of defective, if you want to think of it this way. So at the moment, we're just running at about 40% defective, which is not great, especially when you think of our hoped for upper spec limit of 10%. So clearly we're nowhere near meeting our customer specification. Obviously, we have slightly broken lower and upper control limit on the basis that these are calculated from the actual sample size. So as your sample size evolve, your control limit will evolve. And in blue, we have the actual data. So this is, if you look at your Excel data, each data point will effectively represent almost that percentage defective, if you want. Okay, so the good news, if you look at this chart, the process is stable. We have all our data point well within our control limit. We got a bit close here. If something good or bad, I don't know what's meant to happen after the 25th of January. Well, based on this graph, would say it had no impact. It made no change. Okay, so if I were you, in this case, obviously you could go back, use Control E, and then go back to the scale, a reference line, and remove that line because it's not adding any value for purpose. And obviously, if you don't want to show what was the expected customer spec limit, then you can also remove it, rerun it, and then you have this clean chart. Okay, I hope that makes sense. Obviously, you have seen here where Minitab very kindly confirm, obviously, that these are unequal sample size. Pretty straightforward. The P chart, as you can imagine, is very commonly used. Some people say, well, what about, as you said, if we don't know the whole population, we could use an IMR. And you could. So let me show you what would happen if I just plotted the IMR, or in this case, the IMR. I'm going to put the not timely. Scale again is going to be the date. Okay, I'm going to alt test. Okay, there you go. So it doesn't look very dissimilar, don't get me wrong. And obviously here you notice that the mean calculated is the mean count of untimely loan application. But it's not going to give you a sense of what number of application impact our likelihood to become untimely. This is where having the actual control chart that use the sample size, this is where you can detect it. Now, in this process, it doesn't matter, in part because the sample size were fairly similar from one day to the next. If you had more variation in the sample size, it's not uncommon to see this. Okay, so just a word of caution. Alternatively, obviously, some people say, okay, well, what if I plotted the IMR based on the defective? So let's have a try of that. So I'm just going to bring over the percentage defective. And I'm going to do an IMR of that. And again, it may not look fundamentally different, but sometimes all those little differences will prevent you from being able to detect that something is about to happen. And I think this is what I want you to take from this, is if we look at our initial P chart, the good news is here, if you look at your chart regularly, like every day, you would have noticed, ooh, I got a bit close on the 27th. If you look here, it doesn't say that at all. It says, actually, you're doing pretty good. So this is where sometimes the percentage, good, bad, whatever you're reporting, is fine to report, but using it to monitor the stability of the process may not be the best thing. And this is why, you have to be clear on what you're using your control chart for. Okay, just wanted to show you this example. Again, it will depend on your context, which one is better than the other. Okay, so I'm going to close that. Just bear with me to keep a clean sheet. So the next chart I wanted to have a look at with you is the NP chart. So notice here, obviously for sake of conversation, I show that my number of application is constant. It is 47 in this case. And again, I'm counting the not timely, so this is timely. Notice the proportion are slightly different just for argument's sake. So I'm going to copy this element and run it in Minitab. That control chart, attribute, and now I'm in the world of NP. So I'm going to look not timely. Here I can either put 47 or I can refer to the count. It's completely up to you. I'm going to keep, I need to change date to make sure I pick the right date one. In case it changes, it should be the same, but I don't want to make any assumptions. And the test, all tests, yes, okay. And here's my chart, right? So in this particular team, we have a slightly different picture. I suspect you'll probably immediately pick on first, obviously, all the signals that we have with out of 20 days or 4 weeks. 4 days, we were systematically outside the 3 standard deviation of the upper control limit. But we also obviously have a very clear pattern around cyclicality, with no surprise having a bit of an issue with Mondays. Monday, Tuesday, Wednesday, Thursday, Friday. Ooh, okay, Friday here. Monday, Tuesday, Wednesday, Thursday, Friday. So actually the Fridays are bad days. That's quite interesting. So application that comes in on a Friday seem to not be timely. So that means you need to go and investigate or check your data in case there's something weird happening. Notice that these 2 Mondays were quite high as well. Okay, so this is where, as you start looking at your process and control chart together, as you know your process, you start to thinking, this is really interesting. I need to go and understand a bit more. Because that's the thing, a control chart will point out when you have either excessive variation or some odd patterns, but it will not tell you the nature of the root cause. And this is one thing you need to remember, is that the variation may be excessive, but the true root cause may be very much common to the nature of the process, or it could be completely exceptional. Like if you had system change implemented by IT every Friday afternoon, that may also be something that affected this. I don't know. I need to go investigate. Okay, so that's the whole point I just want you to take away. Now, to illustrate the point of, well, what happened if I'm not quite sure with my volume of data? So I took an example, a different example, again, a different team, so we have different count, where I had the total of application and not timely, right? So this would be another P chart. I'm just going to put that in there. And we're going to see how that runs. So I'm going to do both the P and the NP just to show you what happened if you end up picking a chart which may or may not really work for you. So let's do the P chart first. This one. Okay, so this is an interesting picture, right? And you start thinking, okay, what happened here? Well, what happened is obviously because in this particular team, there were very, very few not timely data. Instead of plotting the zeros, it just leaves a blank because that's what we have. So because we have blanks, it's not calculating the control limit. So in this case, you have 2 options. One is obviously you can go back in your data, bear with me, and put a 0 in there. I'm going to do it one by one so that you see. And obviously, this is another reason. I'm showing you this on purpose so that you know ahead of time how to prepare your data so that you don't have to do these sorts of things. Okay. And now, because I have actual my zeros, I will have the blue line, which will look continuous. I will have a continuous control limit calculated based on my sample size. Obviously, because I have a boundary, effectively, with the fact of having 0 defect, my the area between the center line and the lower control limit and the areas between the center line and the upper control limit will be different. This is what we mean by boundary line, if you ever wondered. So this gives you a particular picture, which is if this was, as I say, it's a different team, different product and process. They were pretty good. There was just this odd day here. Not sure what happened. This is, again, when you go either check your data because there may be a typo, or If this was the first day of the year where everybody's back in the office, or actually they were on the second day and on Monday they accepted the application, but there was really nobody there to process them, this would be perfect explanation. But I don't know. That's the point. You need to go and investigate. Okay. Now this is situations where you have very low count. So some people say, "Oh, what if I had done the other chart?" Well, if you had done, let's have a play with the NP chart instead. We're going to keep not timely 2. We're going to say subgroup size is that. And guess what? It looks the same. But the control limits are different. And this is what I'm saying. Sometimes you really need to know which chart you want, because Minitab will do whatever you tell it. Okay. Case in point, I'm now going to even go and do the IMR just to show you that it can do lots of weird things. Okay. And this is how this would look as an IMR. So just because Minitab can produce the chart doesn't mean it's the right chart. So I just wanted to show you that because it's probably the most difficult element to explain until you've actually shown someone the reality. Okay, so now let's look at the other branch, which is the defects branch. So let's start first with the U chart. Now, just a bit of an intro on the data again to put some things in context. So again, I have, in this case, I know my total population. And really what I'm looking here is the count of defects based on how many days we were waiting for information. Because when we were doing the 5 whys with the team, one of the feedback that had come was, well, sometimes we have to wait for information because, those applications that come toward the end of the week and they need to go through an underwriter. The underwriter needs to receive the loan, evaluate the whole file, and then send back to us. And obviously, if we get the initial loan application started on Friday, but it doesn't get looked by the underwriter until Monday, there's days there because the customer counts in calendar days. It doesn't matter whether we measure it in business working days or not. The customer effectively used calendar days. So the process owner, very rightly so, would say, fine, then we'll measure things in calendar days. And that's when they realize, oh, there's quite a bit of information waiting. So we're not going to look at the timely, not timely, because these are defective, non-defective. We're going to be looking at defects, which is how many days are we waiting for information for our particular application that comes in throughout the week. Okay, so I just wanted to show an example again of how things look a little bit different. So for sake argument, I'm just going to cut this and put it here. And that's what I'm going to paste. Okay, so go to Minitab. I'm going to open a clean worksheet to make things easier. And here we go. So this is my data, these are my defects, and this is my total sample size. So I'm going to stat, control chart, attribute, and I'm going to do a U chart. So the variable is the defects. The subgroup size is the number of application. For the scale, again, I'm going to use the stamp and use the date, and then making sure I get all the tests carried out. And here we go. Oh, that doesn't look good, does it? I mostly have signals of all my 20 data points, which is a bit alarming, but as you probably gathered, not unusual. So again, Minitab tells us we have an equal sample size, hence the broken line. Center line, you have no point on the center line. That's your first challenge. You only have 2 points within the control limit, and everything else, all other 18 are outside the control limit. So this can be looked at differently. From the standpoint of where the data points are, clearly rule 1 is broken very consistently. So you have most of your data point more than 3 standard deviation from the center line, which definitely articulate the point of excessive variation that needs to be investigated. You also notice again that we seem to have a bit of a pattern. So there's potentially some cyclicality in here. But what's also interesting is how they're laid out, right? So if you remember your chart with the different type of pattern, this could also be a form of clustering / mixture. So effectively, you probably have one process going on one part of the week, and another type of process going on another part of the week. And by process, I mean both the type of product or transaction that's coming through, as well as the work setup. Okay. So for example, when you have different staffing choices made, these are the sort of pictures that we see whereby on the days where we have a high volume of staff working, we have some really good performance. And then other part of the week where we are chronically understaffed, then we have very different performance. Now, if this is something which is almost now becoming normal practice in a business, effectively you're comparing apples and oranges. So this is a good graph to use to have the conversation with the process owner and the team. As to what do you do with it, is like, well, I use it to have a conversation. I probably wouldn't use it to demonstrate the process performance. I'll probably just use the baseline and say, okay, and this is where you're going to use your graphical summary. Again, be clear about what you use the control chart for. This is where you need to be a bit savvy about what you show and the message that you want people to take out of it. Okay, I hope that makes sense. And let's look now at the C chart, which would be the situations where now you, for example, may just have counted number of defects. So again, there will be a different population of loan application where I just counted number of days we spent waiting for information. So if you just want to plot the total number of days, regardless of the type of application or teams or whatever you might be segmented by, all you need to do is plot this, go into stat, control chart, attribute, C chart, select total defect, make sure the scale is right, make sure the tests are all selected, and then click OK. And this is the C chart, right? So obviously different team, different situations. We have also 4 signals. This shows a signal in the sense that actually we had very few waiting days on that day, which was brilliant. So this is, go investigate to see if you can learn from this situation, because it might be something that you'll be able to replicate to other situations to overall improve the performance of your process, as well obviously as investigating what happened to these days so that you can learn from it and try to reduce the likelihood of this happening. Okay, assuming again that the data is representative and there is no typos in there. Again, you would also realize that even though it's not pointed out directly by Minitab itself, you look like there's, again, quite a bit of cyclicality. So it tends to indicate that if you have cyclicality, the timing of things is relevant. And this is what we mean by cyclicality or seasonality. Cyclicality seems to be within a particular period that you already have plotted in your data. Seasonality might need to have a number of years to illustrate the principle. So, for example, when we talk about heavy goods sales, which are not sold on a transactional basis, you may need almost like 2 years of data to see the cyclicality in sales. But at that point, because it's span over 1 year, we tend to refer to it as seasonality, because you will compare year on year. So, for example, the sales of seasonal product is a perfect example of things like beachwear or ice cream or that sort of things. Okay, I hope that makes sense. So again, because this is a T chart, you could choose to present it as a proportion, but it's probably not going to be the most useful. You could use an IMR chart. You know, some people have done that. I would probably recommend that you have more than 15 defects, so between 15 and 30 defects before you move to an IMR chart. Again, it's just because you want to have that element of distribution that looks normally distributed. So if you're not quite sure, just go into your basic statistics, graphical summary, plot this, see what comes up. And you look here, clearly the data is not normally distributed. So I wouldn't use an IMR chart. I will stick with the C chart because it is statistically more correct in these cases. Okay. Now, as you saw from my data in Excel, it could be that this total defect is actually the breakdown of 3 types of defect. It could be the 3 types of product that all may or may not be required the underwriting to happen. So I wanted to use this as an example to show you how you can use the multiple graph option in Minitab. And what you would do, you go in Stat, Control Chart. Obviously, we're going to go back to our C chart. And this time, instead of selling total defect, actually, I could even keep it here because it's, I mean, I already have the graph and I've not dropped it. What you do, you select those 3 as well. So you put it into a variable. Make sure, obviously, your date is correct. And then click on multiple graph. And you have a choice. You can use the same axis for reference and unit, or you can keep it different. So I'll show you both, and I'll explain how to play with it. So I'll click OK, make sure I still have all my tests run. Yes, I do. And click OK. And so now, so my total, you'll notice, is on the scale of 0 to 40. And then the other 3 will be on the same scale. So it's quite useful from that standpoint, because then you can articulate which process, if any, is more or less stable with, and therefore where you need to go and investigate. So out of my total defect, I knew had about 4 data points, which were quite interesting. But it turns out that it's mostly defect 1 and 2 that are causing those. Defect 3 is actually remarkably stable. So clearly, defect 3 is not my biggest areas of worry. And so this is where sometimes above and beyond the Pareto that gives you a total count of defect, also looking at, you know, how stable they are can be quite insightful. Okay, just want to show you that. And then finally, the last thing, which is frequently very useful, which I'm going to build artificially here because clearly it's not going to be as relevant, is if you wanted to show how a process evolves over time. So let's say I've got phase 1 for the first 10 data point. And then, oh, I'm silly bunny. Go. Wait, just work with me here. I'll just take 2 seconds. And then I'm going to have phase 2 for the next 10 points. Still using the C chart. I'm going to go that control chart, attribute C chart. I'm just going to go the defect now to keep things simple to show. And on the C chart option, where it says stages, this is where I can indicate my phases. Now you need to make sure when you type the description of your phase, you may use baseline and post-implementation or whichever description you want. But make sure that you have no typos, because otherwise every time there's a new spelling, it will count as a new value. And I tend to prefer that because at least I can fix it. If you select the other option and you didn't include the one which has the typo, you will have 1 data point that will drop out, which is not ideal. So I'll click OK, OK. And now I can see my process. And actually, you see here, it kind of recalculated the center line and the control limit. Don't get me wrong, I don't think it's very meaningful. It's kind of a happenstance, if I was brutally honest. And this is the other thing I will say, is a control chart is not a statistical test. Don't try to use it to say something which is not meant to be used for. Okay, we have control chart to look at stability. We have statistical tests to see if there's a meaningful differences between the before and after. Okay, so use each tools for the right purpose. Okay, and the last thing I will also demonstrate on the C chart, It's not always relevant, but for some people, it makes a big difference because they want to be able to detect early. So in your, for the C chart and the NP chart, so the one where you have a stable area of opportunity or a stable, consistent sample size, you could, if you wanted, go into your chart option, limits, and then indicate that you also want to see the line for 1 standard deviation from the center line and 2 standard deviations center line. And the way you type them is 1 space 2, click OK, and then it created again. So this is what I'm saying. I would tend to recommend to only do it for the C chart and the NP chart, is because if you imagine when you have broken control limit, it becomes really hard to read. I don't find it particularly useful personally, but some people do, and I respect that. That's why the option is there. It's for you to use at your discretion. If you chose not to use them on the graph itself, sometimes it's still useful to have the actual calculated value from Minitab, because those will be using the right constant to calculate, i.e. they will include also an element of confidence interval around those to cope with evolution of the data, which is a bit harder to reproduce in Excel. But then if you want to create as part of your control plan that when the number of days late or waiting for information goes above, let's say 19.86, I'm going to start to go investigate things, just so that it doesn't go beyond my upper control limit. Now, don't get me wrong, if you're already at the situations where 40% of your application are late, that's probably not going to be as useful. But again, appreciating that in different processes, you're in different stage of maturity and you need more advanced tools. So this is one which is quite easily accessible and, as I say, potentially quite relevant. So I just wanted to show it to you. Okay. So with that, I'll just go back very quickly through the main deck to close the session. So just to recap what we've seen, and obviously the conclusion that we made, so that if you want to see how you can present, you can have a sense of that. And again, for the U and the C chart, making sure you identify not only the signal that Minitab tells you, but also show the evidence of cyclicality and telling your process owner there's clearly something going on certain days repeatedly. So the key message is go investigate, check your data, speak with the team, see what's happening, relate to actual dates, which is why it's so important to keep record of the date of data collection, so to put it in the actual context. Because if you say day 4 of data collection, people will not know what you're talking about. If you tell them, this was the 13th of January, oh yeah, that day we had 3 people sick with COVID. Okay, makes sense. I hope this is useful. Also, just as a reminder, because I thought this would be useful for you to have while building your own charts and drafting your own analysis, to have a sense of the typical patterns and what we refer to them as. Okay, with that in mind, I hope this was useful. As always, there are loads of information available online in Minitab Help. If you can, in particular, check it on support.minitab.com. I will be posting more material that hopefully will equally be useful. As I said at the beginning, there's a counterpart for charting continuous data. If this was useful, please like and subscribe, and then let me know in the comments what other topic you'd be interested in, and I'll try to prioritize those in the flow of the video that I'll be producing. Thank you very much, and good luck with your analysis.